Hello. Hello and welcome to the fifth and final tutorial on Python within the series of tutorials on the introduction to software in robotics. In this video, we'll simply enumerate some of the packages, some of the other noteworthy packages that you probably want to be familiar with, just that you know what's out there. We'll look into a package for GUIs called tkinter. We'll go over symbolic math. I should add the link to the documentation here. And sort of the stuff you can do in MATLAB if you're familiar with that. So, calculating gradients of a function, stuff like this, symbolically. Then we'll simply just browse the documentation really for classical machine learning. So algorithms like k-nearest neighbors, you got the what are they called, logic trees, that sort of self-forming logic trees that could be from I'll talk a bit more about their SVMs, stuff like that. We'll look into what you would use to define and train your deep learning model, would be PyTorch. Then there's a nice little package for handling tables. That would be things that you would do in databases, SQLs, but Excel as well, or just simply like working with a CSV. For stuff like this, any sort of table looking thing, Pandas is your best friend. We discussed a bit the deep learning in the previous tutorial on computer vision. And finally, I'll just mention a package for classical control, it also sort of just replaces a MATLAB package, again, if you're familiar with MATLAB. And without further ado, let's get into this. So the first thing is tkinter. I should mention that let me put my face below, get it out of the way. You already, if you saw the video on Matplotlib, NumPy, and SciPy, I did show a bit of the some of the projects where I used Matplotlib, and in one of them, the manipulator visualizer, I could just run it to bring it back. But let's just open it anyway for a refresher. So you get something, with sliders, with buttons, with clicking. Now here we have an embedded matplotlib. That's not the important part. The important part is that you get to have buttons, sliders, tabs, things like this. It was also used in the when I did the detection to change the emojis. The emojis were in tkinter too. Okay, but anyway, here's our documentation for tkinter. You have the tutorials about the introductions, basic concepts, how do you add windows and so on. Of course, if you just go to the first real example, you will get a real example. It has different bindings. I'm not sure what's it written in originally, but you certainly have it in Python. For basic things, this would suffice. Now, I did have to, in my own projects, I did have to massage some of the things a little bit. So if you want to do something super similar to what I had, and if there's enough of a desire, I will go over the code I have in depth. To reveal some of the maybe hidden secrets, I suppose, if you wanna, because I had to do some multiprocessing there to have it work with the other things. But anyway, if you want a basic GUI, tkinter does it just fine. If you import it, I will just say this: if you import both of these things, if I remember it right, then it should be slightly prettier. But I'm assuming that, if you're an engineer of some sort, you can live with a slightly ugly interface as long as it does what you want. Sometimes it's very convenient to have these sliders and change things on the fly as they're as they're happening. It's easier than running the same program over and over again, but with slightly different parameters. So yeah, if you have something really complicated that's difficult to understand, it does. I would say it is sometimes worthwhile to put it in a GUI like this, but you will have to decide that for yourself. It definitely takes a bit of time to set up a GUI that works the way you want it to. Although again, for the simplest possible things, it's fairly straightforward, and you have everything that you would possibly need. Put the objects in a particular place in a grid. Things like this are predefined. They work pretty well, pretty consistently. I'm pretty sure TK also works on Windows as well, so it is portable. It is portable as well. Okay, the next package I want to talk about is SymPy, and let's give a short demo of what SymPy would be. Now this time I'll pause first. Okay, so I did test it to run it first. Yeah, let's just run this little script to see what we have. So this is some function, and in particular it's this function. The printing could be a bit better. There are ways to make it a bit prettier than this, which I didn't really go into. This was okay for me. But anyway, you have this function, and then you calculate its session, and finally we plot it as well. And let's just very quickly see how this looks. So you would define your symbols. You would write the expression, that would be that function, and then if you want to calculate derivatives, you use the diff function. So yeah, nothing too fancy. And then what's interesting to note is that it does work in conjunction with NumPy and Matplotlib. So okay, boring comments. But anyway, we have this session defined, and if we here we print it, figure blah blah blah. Yes, if you take your expression and then you lambdify it, this is we go over the expressions that we have in the list basically, and you tell it to numpy it. Now you have a function that you can throw in a vector and get the results of that function out of it. So you don't have to define a function separately. You can take this symbolic math and turn it into a function that accepts NumPy as inputs, and then you just plot it normally. Yeah, that's where it's called. Okay, that's about it on SymPy. What I do want to add as well is just sort of a word of caution. It is not as powerful as MATLAB's symbolic math package, which itself isn't as powerful as Mathematica. So if you really have something, if you want to symbolically solve an ODE, you probably have to use Mathematica for this if your function isn't completely trivial. But if you want to compute something like eigenvalues of a matrix symbolically, something relatively small matrix, you can do this with SymPy. And of course, there's tutorials on it as well. Yes, and there are the API reference as well. Yeah, so in the API reference you can find the operations that exist for a particular subfield, let's say. Yeah, which is very, very convenient. Very good documentation. You can find what's out there in the tutorials quite quickly, and it's pretty simple to use. Okay, the next thing we have is scikit-learn. It's used for classic machine learning. So everything that's not a neural network, it's in here. I did not use this package extensively as I didn't need it personally, But from what I did use in it, I can say the documentation is phenomenal, truly phenomenal. So you can genuinely use this as a resource to learn classic machine learning, sort of along with the textbook, of course. But if you go to a particular algorithm, there will be a very nice explanation of what's going on, in which context it sits. The math is explained as well. There's a bunch of examples that you can run and sort of tweak to see what's going on. I really cannot, I'm completely blown away, honestly, by how good the documentation of scikit-learn is and how many things exist here as well. So, in the clustering you would have k-means, in the classification you would have SVMs, stuff like this. Oh yeah, random forest, that's what I was trying to remember what it was. Oh, sorry, let it scroll all the way down. So, you can assemble a bunch of different models here. It has, again, the math is explained quite well. So if you're doing, if you have anything that's sort of within the classical machine learning style and you're aware of the existence of the algorithm, maybe some math with it, I strongly encourage you to, as soon as possible, start using it in scikit-learn. It's truly, truly phenomenal. Okay. The next thing is a different kind of machine learning, the deep kind. And for this, I like PyTorch the best. There are, of course, other libraries to define neural networks in. I liked this one by far the most because it truly allows you to define the network and all the functions in the way where you can see what you did. It's very transparent. The way you define a network is very transparent. So if you know your stuff, if you know your tensors, you know what network you want to define, can't miss with PyTorch. And of course, it comes with a whole bunch of tutorials, including the introductory ones. But then everything that exists, all the sort of different layers and activations that you can add are here. For this, you will need to find a way to get your CUDA, your NVIDIA driver with the CUDA as well. I've come to know that NVIDIA open sourced its drivers. I haven't looked into this too much because my GPU on my home server is from 2012 and that's still a closed source basically. But I am told that this should now be much easier to set up. If you are doing AI, what you want is Linux with CUDA drivers on an NVIDIA GPU. Nothing else comes close in terms of ease of use and performance. Well, maybe in terms of performance, yes, but not ease of use. Like the best of both worlds, the best possible trade-off would be that. And I highly recommend PyTorch specifically if you really want to know what's going on. Keras is good if you know what you're doing and you want to do something quick and dirty. But if you truly want to build neural networks, this is it. And you have your videos as well. Fantastic library. If you're doing anything with tensors as well, it might even make sense to use PyTorch instead of NumPy. And the syntax and the slicing is very similar to this too. Great library. Okay, next we have pandas. That's what you use for tables. If we go to these, no, not that, but say getting started, you will see a very quick rundown of what pandas has to offer. So, tables, everything you can do possibly with a table. This initial page is very good. I can't say I got much further than this myself because I am blessed enough not to have to work with tables. Although, I mean, tables are great. We use them because they allow us to do many things. And the people that I know that work with tables, you all use pandas. So great library. And of course, there's a very nice, everything from 10-minute introduction to the introduction to data structures, so on, and every possible thing very nice documentation. You can, just put it in the shell, play around with it. It's a great resource. Okay. And finally, let's mention Python control package, or just control, which serves as the equivalent of the, I don't know, add-on, I guess it's called in MATLAB for control. So if you want to, define an LTI system, do some basic, if it's linear, you want to see a response, you want to see a body plot, things like this. All of the basic things are in this package, and they work. I've also used this quite in a very limited way, but it served my purpose of getting a response out of a critically damped system pretty well. You could find things like this in the documentation. Again, if you know the mathematical theory, this is the least possible amount of effort you would need to do with the software to get what you want. Okay, and with this we can conclude the overview of the other noteworthy packages. There's of course myriads more, but I would say, as I said with the Linux commands, if you learn one powerful set of maybe up to 20. In the case of Python packages, it could be as few as 10. If you learn them really well and all of their options, you can do an incredible amount of things. So I wouldn't recommend that you go and download 200 packages and that you have one package for every particular thing. It's very difficult to know all of the packages and what they do. They could be updated and changed, and then your code would break. But if you rely on the power of these sort of more core packages, and you know how to use them well, you can go incredibly far. I would go so far as to say that, if you're doing math, you kind of have to know these packages. It's not just, also for your own purposes. It's the other people use them a lot. I know that this is a logically invalid argument. Vox populi, do what the people say. But what you get from this is the benefit of this community around these packages is that there's so much questions asked already. There's a bunch of forums where you can find out more. There's tutorials on the video tutorials on YouTube. The documentation, as I hope I managed to demonstrate in this short amount of time, is usually amazing. And sort of this is what you get if you use a popular package. And from my experience as well with things like NumPy and Matplotlib, I've been using them for at least 6 years by now, and they haven't failed me yet. Maybe if I push them, beyond what they're designed to do, but it's very obvious once you start doing something like this. I can pretty much guarantee, from personal experience, that the things that I showed you are really worth your time. If you have an application that they might be useful for. Okay, I hope you are now even more inspired, even packed with motivation and energy to go out and start programming with Python. After this tutorial, the next sort of thing in the playlist would be the start of the introduction to the UR-Simple control library, the simple library to control robotic manipulators. So if you're interested in that, then keep watching, and I'll see you there.